This is a tutorial on how to use a calculator to solve matrix equations. Now we're going to look at a couple different methods we could use on the calculator. So let's start off with the first example. So here we have a system of two linear equations. 3x minus 8y equals 10, and 2x minus 5y equals negative 13. Now one thing we could do is convert this system into a matrix equation. So to do that, we'll take the matrix of the coefficients times the matrix of the variables, the resulting constants on the right side of the equation. Now if we want to be able to solve for these variables, we need to get that matrix by itself. So to do that, we would need to multiply both sides by the inverse of this coefficient matrix, giving us this matrix equation as a result. Now at this point, we're ready to put the data into our calculator. So we can first start off by putting our coefficient matrix into a matrix on our calculator. Let's say matrix A. So to do that, we'll go to second, x inverse, scroll over to the Edit tab, and then hit Enter on matrix A. Now our coefficient matrix is a 2 by 2 matrix. So we'll put that in, and now we need to put in the data. So first we have 3, then negative 8, then 2, and then negative 5. So now we have that matrix ready. Now we still have this matrix with our constant values. We could put that data into matrix B. So we'll go to second, x inverse, scroll over to Edit again, and this time we'll put the data into matrix B. Now this time, we only have 2 rows and 1 column. And so in the first row we have 10, and in the second row we have negative 13. So now we have that matrix ready. At this point we have everything we need to solve for x and y. So first we need to pull up matrix A. So we'll go to second, x inverse, then hit Enter on A. And we need the inverse of that matrix. So we just need to hit x inverse. Now we need to multiply that by matrix B. So now let's pull up matrix B. So now all we have to do to get the result is hit Enter. From this we could see that our solution is a 2 by 1 matrix, where x is negative 154 and y is negative 59. Now let's take a look at one more example that will show us how to solve the same system of equations, but using a different method. So this time we still have our same system, but rather than creating 3 different matrices and putting them into a matrix equation, let's put the entire system into an augmented matrix. Now what I mean by an augmented matrix is that we'll have the matrix of the coefficients fused together with the matrix of these resulting constants. So when we do that, it'll look like this. Now our first column shows us the coefficients for our x variable, and the values in the second column give us our coefficients for the y variable. And then the third column gives us our resulting constant values. So when you look at this, you could think of it as 3x minus 8y equals 10, and 2x minus 5y equals negative 13. So you could think of this bar as like an equals sign. Now what we want to do with this augmented matrix is put it into a specific form that will give us our solution. And that form is called Reduced Row Echelon Form. Now if we're going to find that using our calculator, we need to put this matrix in as if it were just one simple matrix, like this. So let's put this data into matrix C on our calculator. So we'll go to second, x inverse, go to Edit, and then go to matrix C. Now in this case we have 2 rows and 3 columns. So now let's put in the data. 3, -8, 10, and then 2, -5, and -13. So now that we've done that, we need to put it into reduced row echelon form. Now the way we get to that is to go back to our matrix feature, and then go to the Math tab. Now at the very bottom here, or close to the very bottom, we have option B, which has RREF in a parentheses. Well, that RREF stands for Reduced Row Echelon Form. So we'll hit enter on that option. And now we need to put in the matrix that we want to put in that form. So we'll go to second, X inverse, and bring up matrix C. And then close the parentheses. And now we'll hit enter. Now from this, we could see that we have this matrix as our result. But before we do anything to try to interpret this, we have to remember that this was an augmented matrix. So since our original matrix C that we used was augmented, we have to think of our solution as being augmented as well. Now if you remember, the first column represented the coefficients for our x variable, and the second column represented the coefficients for our y variable. And again, our third column represented the constant values on the other side of the equal sign. So when we look at this augmented matrix, we could see that we have one x equaling -154 and one y equaling -59, which is the same exact solution that we had from our first example. X equals -154 and y equals -59. And that's how you could use your calculator to solve matrix equations.